Hey guys, welcome to the YouTube channel of NITA. Today I am going to discuss the problem training session that came in Educational Codeforces around 115. The problem starts with a short story. That is, Monoker is the coach of the Berlin State University program teams. He decided to compose a problem set for a training session for his teams. Now the actual problem starts from here. Monocarp has n problems that none of his students has have seen yet. The ith problem has a topic AI that ranges from integer 1 to n, and a difficulty of BI that also ranges from 1 to n. All the problems are different. There are no two tasks that have the same topic and difficulty at the same time. So it is already assured in the question that all the problems are totally different. Now, Monocarp decided to select exactly three problems from n problems for the problem set. The problem should satisfy at least one of the two conditions, possibly both. The topics of all the selected problems will be different, and the difficulties of all the three selected problems are different. That are the two conditions. That is, either the topics will be totally different or the difficulties will be totally different. Now, your task is to determine the number of ways to select the three problems for the problem set. Let's check out the example for this so we can see how the pairing is, how the triplets are formed. So if I consider this example, that is 2, 4, 3, 4, 2, 1, 1, 3. Now, one problem set that I can form is that that is of 2, 4, sorry, 2, 4, then 2, 1, 2, 1, and another is 1, 3, right? Why? Because here all the here though the topics are same, here the topics are same, but the difficulties here all the difficulties are totally different. So yes, this is a valid pair, valid triplet. Now what are the other ways? The other ways is if I select 2 4, then 3 4, then 1 3. Here although the difficulties are same 4 4, but as all the topics are different, so yeah, this is also a valid pair, sorry, valid triplet. And what another triplet that I can form from them, there is 3 4, 3 4, then 2 1, and 1 3. Here both the difficulties as well as the topics are totally different for all of them. So in total there are three triplets that can be formed out of them. Now if you think of any other triplet, let's say if I take 2 4, 2 4, then 3 4, and 2 1. Here if you see in this topics are also same, and for some other difficulties are also same. So the condition was that at least either topic or difficulty, at least one of them have to be different for all of the problems. But here topics are also same for two of them and difficulties are also same for two of them. So this is not a valid triplet. If you can think of any other triplets, those will also be invalid. Now let's go to the solution approach. Now what is the simplest way that through which I can do this? One of the simplest way is that for finding the valid ones, I have to find the valid ones, right? I have to if I have to find the valid ones, then the simplest will be to first I will take the total. I will find out the total number of triplets. That is, how many triplets can be formed from all the n problems, right? What are the total number of triplets that can be formed? It doesn't matter whether it is invalid or valid. I will take all of them together and I will find out the total possible triplets out of them, and then I will subtract the invalid ones, right? I will subtract the invalid ones, that will give me the valid ones, right? That is my main thing through which I will go with this problem. So how to find the total ones? We know that if there are n problems and I have to select three, if I have to find out how many ways I can select three of them, the simplest thing is NC3. That is the formula for combination. I will find out NC3, that is also equal to n into n minus 1 and n minus 2 divided by 6. That will give me the total. This is the total, right? So in case let's say there are five problems total in total, then the total will total count will be 5 into 4 into 3 divided by 6, right? That is the thing. So it will be, I guess, 10. Now I have to find the invalid ones. Like, what are the invalid ones? Now, for finding the invalid ones, I have to find out what is the condition for being invalid. If I can get the condition for invalid, then I can easily count how many invalid ones will be there. Now, let's figure out what are the conditions for being invalid. For this, I will take an a triplet for this. Let's say 3 3, then 3 10, then 3 2. Now, is this valid or invalid? This is not an invalid one. This is obviously a valid one. Why? Even though the topics are same for everyone, but the difficulties are totally different. So yeah, this is a valid one, valid triplet. Now, if I just change some of the values here, let's say I change this to, I change this to 4 and this one to 2. Now here, this one is invalid because why? Here, the topics are same for these two, the difficulties are same for these two. So both the conditions got violated. So yeah, this is an invalid one. Now, if you observe from this, you will find that for being invalid, uh, two of them will have the same topic value. Two of them will have the same topic value always, and two of them will have the same difficulty value. That is the only condition for being invalid. For being invalid, uh, same topic for two and same difficulty for two of them, right? So that is the condition for being invalid. Now, if I have to take any other example, let's say 5 4 5 3 6 3. Here it is also invalid because here the topics are same, here the difficulties are same. So this is an invalid triplet. Now, how can I count the number of invalid ones, right? My main motive is to count the number of invalid ones, which I can subtract from the total to get the valid ones. Now, for counting those, I will keep two frequency arrays, or I can just use a map in C++ that will keep the count of them. The first map will count the topic, right? First map will count the topic. That is how many problems are there that has three as their topic. I'll just quickly erase this. So in one map, let's say the first map is MP1. Here I will see how many problems are there that is topic is three. So for three there are two problems. For four there is one problem, and so on. Dot dot dot. There will be more problems in the question. And similarly for difficulties, that is MP2. I will name it as MP2. In MP2 I will store how many problems are there. That is difficulty as three. Difficulty is three. There is only one problem. For difficulty two, there are two problems. So that way I'll count them. Now, if I can get the count, then I can simply say that let's say from this one, from this, from this one. If I select this one as my first topic, I will select this one as my first topic, and then for this topic, I have to check how many are invalid, right? For this topic, I will check how many are invalid. So how can I get that? I'll see that how many topics are there. Sorry, how many problems are there? That is three as the topic because it is three. And how many problems are there? That is two as the difficulties, right? So if I say the count of three, that is count of topics, the count of problems that is topic is three is, let's say, x. So in x, I have already one pair this. So I have to subtract that one. So I'll subtract that x minus one. And let's say how many problems are there that has difficulties is 2. Let's say that is y. And I have already taken this one as my uh, main problem. So I'll subtract 1 again. And the total possible invalid pair for that one will be x minus 1 into y minus 1. I'll just quickly do a dry run so that you can understand it better. Let's say the problems are 3 comma 2, 3 comma 3, 4 comma 2, 3 comma 8, 7 comma 2, 10 comma 2. These are the problems. Now I will see. For let's say first I will start with this one. I will see for this problem how many invalid triplets are there. So for that, what I will see, how many problems are there in total that has three as their topic. So there is one, there is two, there is three. But since this one I have already taken as my main one, so remaining are two. And how many problems are there that has the same difficulty of two? So here one, two, three, four, right? And among them, I have already taken this, so remaining is three. And so my invalid pairs, invalid triplets for this one will be six. If I quickly write them, they will be say three, two. I've taken this one. Then I will take that one that has the topic is same, see three, three, and then I will take the other one that has difficulty as same, difficulty as two. That is, let's say four, two. Similar, this is one, right? Similarly, I can take 3, 2, and then I will again take this one, 3, 3, and I will again search for the other that is the same difficulty, say 7, 2. Here 2 is same. Then again I will say 3, 2. Then I will again take 3, 3, and then I will take 10, 2. Right? So this, and my next one will be 3, 2. And now I have taken all the possible invalid pairs that has topic as 3. So I'll go to the next one, that is 3, 8, 3, 8, and then I'll say this one, 4 comma 2. This is also invalid. And then 3, 2, then 3, 8, and then 7, 2. And then the last one will be 3, 2, then 3, 8, and 10, 2. So these are all the six possible invalid pairs, right? So what did I find here? Like if I select one of them as the main element, say I have selected this, then I have to find how many problems are there that is topic is 3, how many problems are there that is topic is 2, sorry, difficulties is 2, and I will find all the possible combinations from them. That will be the multiplication of both of them, right? So that was the simple thing. Now I'll quickly go to the code part. See here, I have taken input through the vector, and as I've said, I'll store the frequency in a map, mp1, mp2, and then I have taken here input, and I have simultaneously store the frequency here by incrementing each of them. And then I have found the total number of possible pairs. Total is that is equal to n into n minus 1 into n minus 2 divided by 6. And then for every one of them, I will select that one as the main element, and then I will find how many invalid are there. How many triplets are there invalid? That I'll do by that is mp topic minus 1 into difficulty minus 1. MP1 stores the count of frequency of topic. MP2 stores the frequency of difficulties. So why I've subtracted one? Because I have originally selected one as my main problem. So I have subtracted one from there. See here, uh, there there are three problems that has three as topic, but I have already selected this one. So I have here written 3 minus 1, that is 2. So that was the thing, and for each of them, I will just subtract them, and in the end, I will print them. Now, there is another approach for this. I can do it in another way, just for that will skip this part, right? If you observe here, like what are the conditions for being invalid? For being in, let's say the three numbers are x1, y1, x2, y2, x3, y3. For being invalid, two x have to be same, two y have to be same, right? let's say if I consider them as the coordinates in a 2D plane, I have a 2D plane on, and all the values I have considered as coordinates, where this one is the x coordinate, this is the y coordinate. So if I for the first two problems, the x is same, the x coordinate is same. So I can mark the 2 points as here, right? I can mark the 2 points as like that, x1 comma y1, x2 comma y2, that is on the same horizontal line, sorry, vertical line. And for the last two, the y values are same, so here x2 y2, and as the y values are same, the third point will be here, x3 y3. So here what does it form? It forms a right angle triangle, right? Sorry, it forms a right angle triangle, that is this one is the corner. So you can also find out what will be the approach here. You have to find out how many right angle triangles can be formed from all the set of points. You have this whole set of points, and you have to find out how many right angle triangles can be formed from them, and the right angle triangles are the invalid ones. So from the total, you will subtract the number of the count of right angle triangle, and that will give you the result. So how can you find out the count of right angle triangle? For that, it is in the Geeks for Geeks website. You simply look out here, see the count of right angle triangle formed from given endpoints whose base are perpendicular or parallel to x or y axis. Here it is the code, um, this one. You can simply go through it and figure out what is being done here, and then use the same to find out there. So that was the explanation for this. I hope you understood that. In case you have any doubts, you can post it in the comment section, and I will try to reach out that as soon as possible. Thank you.